Our next quadrilateral is a special type of parallelogram. It's a parallelogram with 4 congruent sides. That's called a rhombus. When you were learning about this in elementary school, you might have called it a diamond, but it's called a rhombus. And again, it's a parallelogram with 4 congruent sides. So it's a parallelogram and all the parallelogram characteristics, plus add on one more thing, and that's all 4 sides are the exact same thing. So not only are the opposite sides the same, but all of the sides are the same. So when you have that, you do get that diamond type shape here like we have for this rhombus. Notice all 4 sides are marked congruent, and a couple of additional characteristics. So all the parallelogram characteristics plus the diagonals are perpendicular to each other, and the diagonals bisect opposite angles. So let me scoot this up and show you what that looks like in a picture. The diagonals form right angles, and you can see that there in the middle. And then they also, the opposite angles are not only congruent, but they also get bisected by the diagonals. Now that's not true for every parallelogram, but it is true for a rhombus. So again, I've got them marked congruent for the ones that get bisected. So that's the characteristics of a rhombus. All 4 sides are congruent. In addition to their parallelogram properties, the diagonals are perpendicular and the diagonals bisect opposite angles. All right, so here's an example of maybe how we could do some work with a rhombus. Okay. All right, so EKGS is a rhombus, so this quadrilateral to the left is a rhombus. So what I would do right away is I would go ahead and just start marking all the things that we know are true. So all the sides are the same. All these sides are congruent. I know the diagonals are perpendicular and they bisect each other because this is still a parallelogram. I know that the diagonals bisect opposite angles and the opposite angles are congruent. So all of these things are true right away as soon as we know that it's a rhombus. So we've got all those things marked. Now let's see if we can use those relationships to help us with part A and part B. All right, so if ES equals 3x, so ES is this side over here. They're telling me that that's 3x. Well, that automatically means that every single side is 3x. And then they want me to find what GS is, that's this side over here, if I knew what the perimeter was. So the perimeter is the distance around the object. So if all the sides added together were 36, that would be 36, 3x plus 3x plus 3x plus 3x, some of you could even write that as 4 times 3x, is all equal to 36. That would mean that 3 plus 3 plus 3 plus 3, or 12x, was equal to 36. Divide everything by 12, and I now know what x is. X is equal to 3. So everywhere I see an x, I could put a 3. So for GS is 3 times 3, which is 9. So the length of GS was 9. So that's how we did part A. Okay? Part B, and I'll use another color just so it stands out a little bit better. If the measure of angle EKM, and I'll just clean up a little bit here. Hopefully you guys understand where GS came from. All right. Leaving my markings, just getting some of these things out of the way. A little bit of housekeeping. Okay, the measure of angle EKM is 52 degrees. EKM is this angle right here, 52 degrees. Well, I know automatically that this angle right here has to be 52. This angle right here has to be 52. And this angle right here has to be 52, because the diagonals bisect the opposite angles and opposite angles are congruent. So that's why all of those have to be 52 degrees. So find SEK. So SEK is this angle up here, which is kind of tricky. Now, let's see if we could just get a little bit focused here. We know it's not 52. We know it's not 52 times 2. But let's just see if we can pay attention and get this right. If you look at this triangle, ESM, this top left triangle, that's a right triangle. And we know 2 of the angles of that triangle. Well, the angles of a triangle add up to 180 degrees. So right now we know that One of the angles is 90. That's this one in the middle where the diagonals intersect and are perpendicular. We know that that angle that we just labeled is 52 degrees. And then the angle that they want us to find, or at least half of that angle, SEK, is SEM. This angle right here, where I'm going to put that dot, that's SEM. We don't know what that is, but as soon as I know what that angle is, I won't call it X. I'll call it M, or actually I'll call it Y. We know that those three angles should add up to 180 degrees because they're the angles of a triangle. And if I could figure out what that angle is, or as I'm now calling it, Y, if I could figure out what Y is, then I'll also know what this angle is right here, which means I can add them together and get the total for SEK. All right, so let's do that. 90 and 52 is 142 plus Y equals 180. Subtract 142 from both sides in order to get my Y, and Y must be 38 degrees. So if Y is 38, that means both of these angles are 38 degrees. Well, 38 times 2 is what I'm going to need for the measure of angle SEK. So that is 76. Our next quadrilateral is a rectangle. Now, a rectangle is also a parallelogram. It's another special parallelogram. It's a parallelogram with 4 congruent angles. So a rhombus had 4 congruent sides. A rectangle has 4 congruent angles. And because they all add up to 360 degrees, and they're all the same, 360 divided by 4 is 90 degrees. So that's how we know that all the angles of a rectangle are 90-degree angles. So notice that all the sides are not the same, but all the angles are indeed the same, and they're all 90-degree angles. So some characteristics of a parallelogram, of a rectangle. You got all the parallelogram characteristics because a rectangle is a parallelogram, but then in addition to that, the diagonals are congruent. So this is something that a lot of construction workers will use when they're measuring and they're building, when they're doing your doorways or flooring, and they want to make sure the corners are indeed right angles. Instead of trying to measure the angles, they'll just make sure that the surface, the door or the floor or the ceiling or the wall, are all rectangular. And the way that they can make sure it's rectangular is to make sure that the diagonals are congruent. The diagonals are congruent. So not only do they bisect each other, but they're the exact same length. So LN and MO, exact same thing. So in addition to all the parallelogram properties, opposite sides congruent, opposite angles congruent, diagonals bisect each other, consecutive angles are supplementary, then you can add on 4 right angles and the diagonals are congruent. Here's an example with a rectangle, and we will see how we can put this in motion. So right away, as soon as they tell us that it's a rectangle, I'm going to go ahead and mark that all of these are right angles, and that we know that all 4 of these pieces are congruent because the diagonals themselves bisect each other and are the same thing. All right, so now let's work through the information in part A. MT, which is this diagonal from M to T, is 27. AP, which is half of the diagonal from A to H, it's 2x minus 2. I want to solve for x. Well, 27 is not only the length of MT, it's also the length of AH. So AP is going to be half of that. So AP is half of 27. Well, I don't love thinking about fractions. So this is the exact same thing as saying I need 2 APs to get one of those 27 length diagonals. Okay, well that's a little bit easier for me to think about because that way I'm being able to keep it without fractions. So that means now I'll substitute in for AP. 2 times 2x minus 2 is equal to 27. Distribute, and I get 4x minus 4 is equal to 27. I'll add 4 to both sides. 4x is equal to 31. Divide everything by 4. And x is equal to 7.75. Okay, and all they wanted was x on that problem there. All right, let's move over to B, and I'll switch colors to help out. The measure of angle MAH, that's this angle right here, is 31 degrees. All right, so now I'm going to replace this with 31 degrees. And I want to find the measure of angle MHA. So that's this angle right there. All right. So why don't I just call that y so we could use it as a variable. Oh, let me fix that. And I'll just put a y in here now. Okay. So now they want the measure of that angle. Well, similar to our earlier problem, the angles of triangle HAM, that's this left side, top left triangle, MHA or MAH or HMA, all of those are the same triangle. That's a right triangle with the angles 90 degrees, 31 degrees, and y, and all of those should add up to 180 degrees. Now, we knew the angles were right angles because it's a rectangle, and we know that the angles of a triangle add up to 180 degrees because all triangle angles do that. So I'm just going to solve for y. That's 121 plus y is 180 after combining like terms. Subtract 121 from both sides, and I've got that y is equal to 59 degrees. Our final special parallelogram that I want to talk about is a square. A square is a parallelogram with 4 congruent angles and 4 congruent sides. So essentially, it's both a rhombus and a rectangle. So all my characteristics are everything that a rhombus is, everything a rectangle is, everything a parallelogram is. And I've drawn you a picture here. That's why squares are so nice. Squares have all sides are the same, all angles are the same. It's equilateral and equiangular. So whenever you have a square, it's got all the characteristics of a parallelogram, all the characteristics of a rhombus, all the characteristics of a rectangle. This is what's known as a regular polygon because it's both equilateral and equiangular. All the sides are the same and all the angles are the same.